Hi guys, I'm Eddie. Today I want us to look at the low-hanging fruits which we find in physics paper 1, which is basically some easy marks that you can easily collect. So the video for today, my main focus is on definitions, right? But the low-hanging fruits in physics, if you are carefully prepared and you have learned quite well, there are enough easy marks that we call the low-hanging fruits for you, that you can find in your physics paper 1, so that you can easily score 40% or plus. You can score up to 50% or so, depending on that year, if you are very lucky. Right, these low-hanging fruits, guys, we usually find them in definitions. You can find them in Freebody Diagrams. You can also find them by just correctly choosing a correct formula, but also through your correct substitutions, right? Since I'm going to focus mostly on definitions, let's have a look on definitions, right? I'm going to page through the whole question paper for one single year, from question 1 up to question 11, right? Let's have a look. These are the keywords that one should take into consideration for you to know which questions requires you to give some definitions. Fine. If you find words like state, if you find define, you can also find another one saying describe, and another one can say give. This is normally the words that you would find in questions. But there are also some other ones which you would want you to just egg out if you need to give a definition, right? Let's have a look at this. This is a multiple choice question, which is question 1. The question is saying, according to Newton's second law, the acceleration of the trolley is, then there is one or two words which are needed for you to complete there, so that you get your full marks, right? Let's have a look on the Newton's second law, that if one was in a position to give the Newton's second law, then it was easy for you to score that mark, right? I'm going to underline the keywords. When a resultant net force acts on an object, the object will accelerate in the direction of the force at an acceleration directly proportional to the net force and inversely proportional to the mass of the object. So if you can read the words that are in the question, you can see that if you can take the words trolley is inversely proportional to those words, once you can get these words, then it means that is the part that is missing in that statement, so that your answer becomes a D. So you can see that for only knowing the definition, then it means basically you should have scored that question very correct, right? Let's have a look on another question. This is question 2, which is the Newton's second law. Let's go through the question and see which one of the questions there require us to give a definition, right? That is the question 2.2.1. It's saying a massive rock from other spaces is moving towards the earth. 2.2.1 state, meaning that is either a definition of the law that is needed to give in words, right? This is the law now. Each body in the universe attracts another body with a force that is directly proportional to the product of the mass and inversely proportional to the square of the distance between the centers. I'm actually putting that one in terms of the mathematical expression of that one. So this basically, you can have an overview of this one, and that would even help you to make your life easy. So I'm going to break this for you into two statements. F is directly proportional to product of the mass of the two objects, and also inversely proportional to the square of the distance between their centers. So I've broken the formula into two, where the first part, F, is directly proportional to the product of the two masses and also inversely proportional to the square of the distance between their two centers. This is how basically you can give the law in terms of words, but deriving it from the formula that will be given in the formula sheet, right? Let's have another question. The other question is question 3, which is on a vertical projectile motion. As you page through this question, going through it, you can see that this part of 3.1, it requires one to know the definition of what free fall is. But free-fall motion, if you know this free-fall motion, the definition of free-fall motion, then it is easier for you to answer that question. A free-fall motion is the motion of an object under the influence of gravitational force only. So why is the ball considered to be in free fall during its motion? Because the only force acting on the object or acting on the ball is weight, which is basically the definition of free fall, right? Let's have a look on another question where we can find the low-hanging fruit. That is the question on momentum. If you look at question 4.2, state the principle of conservation of linear momentum in words. Right. Stating the principle of conservation of linear momentum in words, you should bear in mind, guys, that for any conservative law, what you need to know is there are keywords that should be there. The keywords like total and isolated system remains constant. So in this case, we need to know that if it is a conservative law, we need to say total and the physical quantity, which is linear momentum, total linear momentum in an isolated system remains constant. So the keywords should be total and isolated system. These are the keywords that you should always make sure that they are there in any conservative law. Right. Let's have a look on another question, which is the question on work, energy, and power. Let's go through the question and see which part of the question requires us to give a definition or to define any law or some kind of terms, right? 5.2 is saying state the work energy theorem in words. But guys, you should bear in mind that the work energy theorem is always given mathematically in the formula sheet as W net is equal to delta K. So you can also derive your answer in words from the formula that is given on the formula sheet, where you can translate each and every symbol that is given in the formula into words. Like for this case, we can say net, which is that work, which is the W, equals, which is the equal sign, then this delta, that is change, then K, that is in kinetic energy. So I've derived the answer for this from the formula that is given in the formula sheet. So here, let's have a look on it in full. The net, which is that net work on an object, is equal to the change in kinetic energy. That is what is very, very important. So your definitions are very important, guys. Let's have a look on another question again. That is the one on Doppler effect. Question 6, one on Doppler effect is saying state the Doppler effect in words. So the Doppler effect in words can easily be stated as the change in frequency of a wave. The change in frequency of a wave due to the relative motion between the sound source and the listener. This is the shortest version that you guys need to remember. Right. Other question, as you can see, each and every single question is basically having some kind of definitions. So we are going to give you out a pamphlet which is basically having all of these definitions for your practice, guys. So let's have a look at this one. State the Coulomb's law in words. Also, it's still stating a law in words. Stating the Coulomb's law in words, you can also start from this one, from the formula given in the formula sheet, where F is equal to K Q1 over Q2 over R squared. So from this one, you can find out, you can eke out the law in words, where I can break it into two by saying F is directly proportional to Q1 over Q2, and also the second part, which will say F is equal to 1 over R squared. Right. When you say it's 1 over R squared, like that. So I'm putting this one into words now. This will be that one, where I'm saying electrostatic force exerted by one point charge on another point charge is directly proportional to the product of the magnitudes of their charges and inversely proportional to the square of the distance between them. This is the relationship that I've separated for you from the main mathematical formula that is given there. Right, let's move on now. There is another question which needs us to give a definition, which is, in this case, it is saying describe the term electric field. Describe the term electric field. So when we are describing the term electric field, it is a region of space where an electric charge experiences a force. So we are having this one, this region which is around this main charge. So all these regions of space around an electric charge here, if we put another charge, it will experience some electric force. So all these regions which I am represented with a dot represents an electric field. Right, then we've come now to another section, which is that one of electric circuits 9.1, which requires us to state the Ohm's law in words. Stating the Ohm's law in words. The Ohm's law in words is very easy to state. Potential difference is directly proportional to the current at a constant temperature. So we are saying this is basically the most common way of the formula that we know of the Ohm's law, where this one is saying potential difference is directly proportional to current. So now in this case, we need to know that R is constant. So we are saying current and voltage is directly proportional, provided there is a constant, which is the resistance in this case. Right, so that is how we can easily state the Ohm's law in words. Fine, there is another simple section, which is this one of electrodynamics. Basically, in this one, we are not required to state or describe the law per se, but we need to give the name of the law. So in this case, the name of the law is Faraday's law. Faraday's law of electromagnetic. Faraday's law of electromagnetic induction. You don't need to write it in short, just maybe either saying Faraday's law only, that will not be correct, or just saying law of electromagnetic induction. You should write it in full as Faraday's law of electromagnetic induction. Right. Also, just knowing the structure of these machines, either a generator or an electric motor, those are other easy marks that one can collect. So in this case, if you are to label our R is equal to the coil, and also T, which is equal to the brushes, then also X, which is equal to the slip rings. Right, so this is basically some easy stuff that no one needs to know. Then the last question, which is the one for photoelectric effect. If you go through your question, you can see that the first part, which is 1.1, it is 11.1, it requires you to define the term photoelectric effect. So in this case, photoelectric effect, it is when light of suitable frequency strikes a metal surface, then electrons are ejected. That is when photoelectric effect have happened. So in this case, it was fine for you just to tell us that when light of suitable frequency shines on a metal surface and electrons are ejected. Now that, guys, we have seen that every question had at least one definition or simple statement, and so far for these 11 questions, that adds up to about 24 marks, which is almost 16% out of 150. But not only that, there is another section where we can also get some easy marks, which is now on Freebody Diagrams. Let's have a look on Freebody Diagrams.